Today, I will be discussing about the chi-square test. And in chi-square test, there are observed values and expected values. And observed values or expected values, there may be a difference. And that difference, whether due to randomness or because of the relationship between the variables concerned. So this is the matter of concern in the chi-square test. And in the chi-square test, you must remember that there are qualitative variables. And qualitative variables are such as, for example, gender, political parties. Gender, political parties, all are the categorical variables. That is, they do not bear any numerical values. So chi-square test tries to find out any association or relationship between the two variables concerned. The characteristics of the variables are categorical, and this is the use of chi-square test. With the example, we will try to clarify this before going to the example. At first, we like to spread some light on the assumptions of the chi-square test. There are 4 assumptions in the chi-square test. The first, both variables are categorical. Okay. Second, so both variables are categorical, that is the qualitative. The second assumption is all observations are independent. All observations are independent. All observations are independent. Third, the third assumption is cells in the contingency you have mutually exclusive. Contingency tables are mutually exclusive. Cells in the contingency table are mutually exclusive. Okay, cells in the contingency table are mutually exclusive. And what does it mean? Mutually exclusive means an individual, for example, prefer political party A. Simultaneously, the particular individual cannot prefer political party B. Suppose you are going to flip a coin, and after flipping you have head or tail, but at the same time you do not have both. So here the variables are mutually exclusive. Here the events are mutually exclusive. So cells in the contingency table are mutually exclusive. Each individual does not prefer political party A and political party B simultaneously if the gender is the matter of concern and political parties are the two categorical variables. Suppose there is a query that if there is any association or relationship between the gender and political party preferences. So, gender means male and female, and political parties, for example, A, B, and C. So, an individual, male or female, may not prefer political party A and political party B simultaneously. So, they are mutually exclusive. Now, the next, expected value of each cell. Expected value of each cell should be 5 or greater. Okay. So, expected value, when you calculate the expected value, the value should be 5 or greater, but at least 80% of the cell should have that type of expected values, that is 5 or greater. Okay. Now, how these are the assumptions, and with an example I try to clarify these examples. Okay. So look, now I am now look, example. Suppose political party A, B, C, male and female. Okay. Now I put the data 1200 900 400 1100 950 5000. These are the observation. Look, here the political party A, political party B, political party C, that is categorical variable, and male and female gender, that is gender, political party. Okay, so these are both are the categorical variables. Now, second assumption was that all observations are independent. These six observations are independent because male prefer a political party. The number of males are 1200. So they prefers political party A. So this observation is independent of this. That is, male prefer 900 male prefer B political party. These both are independent. So all the observations are independent. Okay. The next assumption is cells in the contingency tables are mutually exclusive. As I have mentioned, what is the mutually exclusive? And with an example of flipping a coin, I have tried to my level best to clarify this concept. So here an individual may not prefer political party A and political party B at the same time or simultaneously. That is, for that reason, that the cells are mutually exclusive. In the contingency tables are mutually exclusive. Now, the fourth assumption, the expected value should be 5 or greater. So, how this expected value can be calculated? The total of these, now total, and here is total. So, total is 2300 1850 900 and 2500, and here also 2550 5050. Okay, so these are the total number male and female, and out of this 2500 male responded in such a way, and out of 5050, that is 2550, female responded in such a way. Okay, in such a way. So these are the row total. This is the row total, the first row, and this is the second row. This is the second row total, and this is the column. This is the first column total. First column total. This is the second column total, and this is the third column total. Okay. So now expected value can be calculated in such a way that is row sum, that is 2500 multiplied with column sum 2300 divided by total sum 5050. Okay, so in this way you can have the expected values for this observation, expected values for this observation, and expected values for this observation, for this, all this. Okay, observations. Now the value, if you calculate, simple calculation is there. If you calculate it, the value will be 1138.50. Okay, so we should put here the expected value. Now I am moving this. Okay, so now expected value, that is male, it is female. Okay, male is 1138.61, 1161.38, and B 915.84, 934.15, 445.54, and 454.45. Okay, so these are the expected values. These are the values expected by just calculating the formula, that is the product of row sum and column sum divided by the total sum, and this is the expected values. And the same way, now you have to find out the value of observed value minus expected value whole square by expected value for each cell. This cell, all these cells. For all these cells, we have to find out this value. So what is the observed value? Observed value is given in the problem, that is, here the observed value was 1200. This is the observed value. This is the observed value in my problem, and for this this is the expected value, the observed value. I am writing the table again, then it will be better. A, B, C, male, female, 1200, 900, 1100, 950, 400, 500. These are the observed value. Okay, these are observed value, these are the expected value. Now the formula is observed value and expected value for this cell. So observed value 1200 minus expected value 1138.61 whole square divided by expected value 1138.61. Okay, simple calculation. Just calculating in the calculator, you have the value, that is 3.30. Okay, 3.30. In the same way, for this observed value, 900 minus 915.84 whole square, 915.84. Okay. So after calculating simple calculation, you have the value that is 0.0274. So for this observation, now for this observation, so observed value is 400 minus expected value is 445.54 by expected value 445.54. This is whole square. After simple calculation, you have 4.65. Okay. So now there is this value. So now for this observed value, 1100 minus expected value 1161.38 divided by 1161.38 whole square. After simple calculation, you have the value 3.24. Okay. So in this way, if you have this observed value, then you have 950 minus 934.15 by 934.15 whole square equal to, after simple calculation, you have 0.26. Okay. So for last, the 500. For this observed value, the value of this formula, if you use this formula for this value, so 500 minus 414, this is the 454.45 by, this is the whole square, 454.45. After simple calculation, we have 4.56. So we have the value depending on this formula. Now we have, and now if we put this value in such a way, for example, here I am writing male, female, A, B, C. So for A, on the basis of the formula, we have 3.30, and for B 0.27 and 4.65 and 3.24, 0.26 and 4.54. So these are the values on the basis of this. Now you know what is the chi-square value. You know. So chi-square is nothing but the chi-square, the summation of this. Okay, so you have these values. Now you sum all these values, add all these values, then you have the chi-square value. So chi-square equal to 3.30 plus 3.25 plus 0.27 plus 0.26 plus 4.65 plus 4.54. So ultimately, adding all these values, you have 16.315. Okay, so now you have the calculated chi-square test. Calculated chi-square value. So then the calculated chi-square value is 16.315, and table value on the basis of the degrees of freedom. Here the degrees of freedom, because the categorical variable particle per T is 3, so 3 minus 1, and gender 2, male and female, so 2 minus 1, take a product, then 2. On the basis of these 2 degrees of freedom, the table value of the chi-square is 15.991. 15.991 is 15.991. This is the table value. And the calculated value is 16.315. So naturally this value is greater than this. Okay, naturally this value is greater than this. Now, if you draw the chi-square distribution, then if this is the critical value, that is the 15.991, this value must lie here in this region. This is the rejection region. So we reject the null hypothesis. What is the null hypothesis in our example? That there is a relationship of association between the gender and the political party preferences. And what is the alternative hypothesis? There is no relationship, no association between the gender and political party preferences. So we reject the null hypothesis. It means that there is no association or relationship between the gender and political party preferences. So this is our conclusion, or this is our findings on the basis of the chi-square test. So here we reject the null hypothesis. This is our conclusion. Okay. So in this lecture, I try to clarify the chi-square test, the definition of the chi-square test, and the definition of the chi-square test and the assumptions of the chi-square test, and we have tried to clarify all those four assumptions, and with an example we have a clear idea how to use the chi-square test and how to calculate the expected value and the formula, that is observed value minus expected value whole square divided by the expected value, and how to calculate the chi-square value, and how to compare the table value with the calculated value, estimated value. And here is an important term, that is the degrees of freedom. Here there is two categorical variables. One is gender, another is political party, and there is A, B, C political party. So 3 minus 1 multiplied with 2 minus 1 gender, male and female, 2 minus 1. So ultimately we have two degrees of freedom. Just looking on the basis of the degrees of freedom 2, we have the table value 15.991. So we have found that 16.315 is greater than 15.991. So here we reject the null hypothesis. Thank you for enjoying this lecture.